Hello and welcome to the next webinar in 12D's training webinar series. My name is Lisa Stewart and I'm the Marketing and Communications Coordinator at 12D Solutions. 12D's training webinars showcase common industry challenges, taking a close look at industry best practices and how these can be implemented using 12D products. The aim of these webinars is to upskill 12D users and broaden their understanding of the capabilities of 12D products. We run these webinars regularly and record them for posting through our website and on YouTube. The previous webinars from this training series, as well as the webinars from our Industry Solutions series, are all available on our YouTube channels if you missed those. During this live presentation, you'll be able to type your questions along the way, as shown on the screen, and we'll answer as many as possible throughout the webinar. At the end, I'll email your questions to the presenter for his insights. Today's webinar will be presented by Peter Tainton, who has over 20 years of experience in various facets of road design. Peter has been engaged in large projects for several major councils and government road authorities and has worked closely with our programmers in the implementation of a variety of design features within 12D model software, including the super-alignment and design speed tables, construction subgrade detailing, design geometry components, overlays, pad design interface, and visualization. Today's presentation is episode 3 in this new series. It's called Subsurface Utilities. We'll look at conduits and trenching, lighting and pits, stormwater, sewer and water trenching, pit and chamber creation, and attributes. Over to you, Peter.
Thank you, Lisa, and welcome everyone to our third webinar on Trimesh BIM Objects within 12D. As per the introduction, today's session is on Trimesh Objects for subsurface utilities. In a previous webinar, we looked at the Trimesh Create, Edit and Apply, and just in recapping, shipped with 12D is a variety of shape definitions that can be applied to form Trimesh features, such as landscape and construction fences, safety barriers, wire ropes, guardrails, retaining walls, bridge profiles, road profiles, and for today, service and drainage trenches. The definitions are stored in a standard file called 12D Trimesh Node Link.4D, which is to be found in the setups area. The file can be copied from here to your user or working folder, and the format is XML. The Trimesh shapes are applied to strings in relation to vertices and segments, so it is therefore imperative that the strings you use are valid strings. So no null levels, vertices crossing over or going back on each other, or closed strings that are not supposed to be closed. Attributes play a large role in the Trimesh creation and their export to IFC. Attributes can come from survey or design strings, and also project attributes. Attributes can be set to the Trimesh object created and also can be used as part of the creation. In my short presentation, I will set and use attributes from the global attributes and also the Attribute Manipulator. The attributes I talk about are under Utilities Attributes. There's an Attribute Manipulator and a Global Attributes. There's also an attribute toolbar, so we'll be looking at that today, or using that today. From the global attributes, we'll just go to the set one and just discuss a few of these first. So again, we're going to also look at first some service chamber creations. So we can actually set attributes to that, and this is using service chamber Trimesh. So there's the attributes for the rectangular pit, extended, circular, and custom. So this is where we're going to set attributes inside my job, mimicking a survey pickup. But obviously you can use the surveyor's attributes as well to define the depth and size of the pits. So under services, we'll look at some information we're going to apply to our Trimeshes, some dial before you dig and so forth information. The Trimesh profile one is one of the ones that we're going to use to edit and modify our Trimesh trench shape as we apply it. So it's going to have an option to extend the Trimesh to a tin surface. Rather than just setting an attribute, it's going to set an attribute that we're going to use as part of the creation. So under drainage, this is another one that would actually just set some attributes to your Trimesh, typically under a BIM heading for export to IFC. So we're just going to set some information about the particular Trimesh trench. The last one we'll look at is the project. This is a side option. So these are some attributes that I just set for today. And again, these are all user definable. You can also, under global, you can edit these attributes and add your own. But here we're just setting some attributes for the particular project. So it's the role of the attribute manipulator to access these attributes and then export them with your Trimesh out to the IFC. As far as the attribute manipulator goes, we're going to look at a couple of things. First off, we'll look at the project details. So again, the projects that have been set using the global attributes. Now I want to know what I want to do with those attributes. So we're going to take those project attributes and we're going to set them as a string attribute to the Trimesh. We're going to use the BIM prefix for our attributes. And we're going to have so when we export to IFC, we'll have a project tab with this information here. So if we go and look at our drainage, the same thing, the one that we set for that. So when we do create the Trimesh, there's lots of attributes attached as string attributes to the Trimesh, and some are useful to you, some are just part of the process of the creation of the Trimesh and more for the internal workings of 12D. So out of the ones that are string attributes here, I've just cherry-picked a few that I want to output to BIM. So I've got the reference string, the calculated length, the Trimesh name, and the volume. So those are string attributes are then copied under BIM, and we have a tab called drainage when we go to the IFC. So again, we're only using that BIM attribute because that's the option when we export to IFC. There's an IFC attribute tree requested. And again, I'm only using BIM, but it can be replaced by any suffix that you want. So inside our BIM export IFC, so again, this is where the attribute is. So we've got a tick box saying use IFC attribute tree, and I'm just using BIM. As I said, that can be user defined. You can call that whatever you want. But every attribute tree under that will be exported to IFC, and any other string attributes that may not be necessary are not exported. So to start with, we'll have a look at our survey pit chambers. So we'll look at creating some pits and chambers from survey strings. These strings on the screen represent survey strings. We've got the circular manholes and some water meters. So we're going to have use attributes to define the shape, depth, and size of the pit. And again, these attributes can be user defined. I've just set them using the global attributes within 12D rather than going out and surveying myself. So I'm using the Trimesh service chamber. So if I look at the circular ones and go process, I've already set all these circular pits, but we can use the single picker to see what we actually did set. So I've just set the same thing for every pit, but obviously each one would vary depending on their situation. So I set the attribute for the depth, for the diameter and the depth. And if I then go and select the rectangular one, and again, I'll select the pit here. We'll also set some information about the attributes for the length, width, and rotation, and so forth, and depth of those meters. So when we want to run those, we go to our service chamber menu. Again, I've obviously done these things before just to speed things up for you. So these are saved as a function. So for the Trimesh sewer manholes, we're doing a circular manhole. So you pick our model, and then you specify the attribute that defines the depth in this diameter in this case, and the depth. If this was if I hadn't set these and knew what these attributes were, and this was coming from survey, you can use the seed string select to pick your string, and it will then give you a list of all your attributes. You just have to pick one of those, copy, and then paste down the bottom. So this is a quick little easy way to be able to get that attribute rather than having to type it. So we're going to look at the pit here, use these attributes to create the tri-mesh itself. Under settings here, there's an option for the wall thickness and the floor thickness. So we've created our tri-mesh. If we now go and grab the water meters, again, it's a rectangular one. So it's going to use attributes for the length, the width, and the depth, and process. So I go and look at my survey, that's the pits that is created for me. So again, however you get those points into 12D, and they would obviously have varying attributes to define the actual pits themselves. So service strings themselves come from survey or design. For the survey, it may represent a dial before you dig, services that were exposed at the time of survey, or potholed on site. While the design service could be a 3D string with a diameter, or be part of a stormwater, sewer, or water network. So for the conduit survey or design that is not part of a network, just a 3D string with a diameter, we can use a single trench that has a width set and a nominal depth. So examples of those sorts of services would be the COM surveys that you pick up, electrical, gas, and so forth. So under the BIM Objects Create Edit, we'll just look at our setups area and a couple of those types of ones. So for the electrical, we're looking at a 300 wide trench. So if we go preview, look under my segment. So this is just a simple rectangle, okay, and its size properties is 300 by 300. And it's just to define a general trench. So it's given a name, trench, and it also has an attribute. This is the attribute we referred to before, which is one that's going to be used as part of the creation of the tri-mesh. So in other words, it's the tri-mesh profile, extend tri-mesh to 10. So when I pick on that and go continue, I've set as part of this profile for it to always extend the top part of the trench, and it's the name of the tri-mesh created is called trench. So when I apply this particular profile to my strings and I specify a tin surface, it will automatically extend up to that tin surface for me. So same, I set up a couple of example ones so that you can edit these and create your own. So I've got a couple of ones for gas, communications. They all look pretty similar, and they've all got a nominal depth and an attribute to say extend to the tin surface. For a little bit more complicated things like the drainage and the water and the sewer, they're to represent networks, drainage networks. So when I go preview on the drainage network one, it looks a little bit odd. Okay, so what basically happens here is there's profiles, trenching profiles, drawn as a 12DA file, shipped with 12D, and there's one for every diameter from the 300 up to I think it's about 2400. So basically here we've read all are read in, but when we apply it, you'll be able to see each individual trenching applied to its own diameter. And there's a couple other things in there for under lighting, pits, and so forth. So these are just 12DA objects that I have created. So you can create your own 12D objects and position them at 0, 0, and then use those around your system. So when I look at the network, I said we only got a short amount of time, so we'll try and get through as much as we can. So the profile we're going to look at for the stormwater is made up of more than just one trench. It has a foundation, a haunch zone, an overlay zone, and a backfill. It's the backfill part that's going to tri-mesh is going to be extended to the tin surface. So if we have a look at our apply, again, I've already saved these as parameter files just to speed things up. So we look at our stormwater trenching, read that in. Right, so we're looking at a model, which is our network. So as part of this process, we're going to be looking at as I said before, a tin surface to extend our trenching up to. So the tin surface in this job is a super tin. So on the screen there is our pavement tri-mesh, which includes our pavement layers plus our curbing, and a super tin. And the super tin is a combination of the existing surface down through the design and then underneath the subgrade tin and back up the other side. The Trimesh the Trimesh for the road can have a blending attached to it. That's under BIM blending as well. So if I get rid of my mesh pavement, then you'll be able to see that there's just the actual super tin, the existing road, the design on the side, and then the subgrade tin surface. So we just get rid of that, and we'll just get our surfaces. So we're looking at our drainage network. We've picked up our drainage trench off our setups area, and we just defined a 1 meter regular interval along these strings, on these links, to sample the cross section and also any tin that we may specify. So we go process, and then it'll then turn around and create the Trimesh trenching for me. So now when I go to my section view, it's a little bit easier to understand what those profiles were about that we read in before. So now you can see that this one is particular for this diameter. So it's got a foundation zone, it's got a haunch zone, an overlay zone, and a backfill. So the backfill is the one that's been set using the global attribute to extend up or down to a tin surface. So when we apply the tin surface, this backfill will go to the bottom of the subgrade, and this one will extend up to the tin surface. So again, I'll go and grab the surface. We've got a clean model here, so we just have to go process. So now if I regenerate my view, you'll see that the backfill has been cut down to the underside of the road and gone up to there. I go back to my section view. You can see the top of the Trimesh following the profile of the tin surface. So again, I want to also be able to add some extra information to this drainage trenching. So I go to the one we talked about before, the drainage trench. It's just some extra information that I want to apply to the Trimesh. So I go set and then process again. So now there's a bit of information applied to it. So if I go F8, which is check my attributes. Okay, so what I've got here for all the Trimeshes, it will have some string attributes applied, and it'll reference the link name, whatever the link name was, the calculated length of the Trimesh, the volume of the Trimesh itself, and the Trimesh name. So as I said before, there are a couple of other attributes here that you don't really care about that much. So these are the ones that are cherry-picked using the Attribute Manipulator to then output to the BIM environment, but it's done at the last process. What is under here is the drainage ones that I just specified over here. So this information has already been set to the Trimesh, and when we finally finish for today, we'll run the Attribute Manipulator to get this a bit of information and also attach that to our drainage tab. Same for the sewer. So if I grab a sewer trenching and read that, it's also set up, so it's also got a profile of trenching. It's got an embedment layer and a backfill to also extend to the tin surface. So if we go process on that, you'll see it create the Trimesh here at this point and then extend up to the tin surface. So I go to here, here's my sewer over there. So if I go regen, it then extends the backfill up to the underside of the road. So again, we can attach other information to that as well. So if we go to our road profile, or our profile for the road, plus also any survey attributes, we've also got the ones for the lighting. So we can grab the lighting ones, read that in. So again, it just says, picks up the lighting, says I want a pole at every vertice, and it just runs through and creates those poles. So these strings were just the strings drawn around where the lighting is supposed to be. So again, same goes for the pits. Read that in. And again, these are just coming from the standard file. Process that, and then it creates the small pits here for you. But it's really the services out here that I'm more interested in as well. So these are the string services that have been either picked up by survey, or you may have used the SuperLine to actually create these strings. But either way, we're going to look at our comms trenching. So if I bring up my attribute and I pick the comms trenching, this is a survey string. It does have a bit of information. I've just positioned this under a tab called Survey under BIM. but it could be anywhere. But generally, the information that's on that existing string has to be under a heading like survey. It can't just be a string attribute on the side on its own. So that information I want to copy from the string that I pick to my Trimesh trench. So that's what this is for. So the attribute path to copy from the data source. So I just type in BIM. If this was a survey on its own, I would type in survey. So that then will copy that information to the Trimesh at the same time as creating it. It's going to do the same thing as before. It's going to grab the trench and extend it up to the tin surface. So again, I run through that. If I then go and pick the Trimesh created, it also now has the survey information attached to it. So again, it does have those extra things before, but the attribute manipulator will take care of that data at the end. So again, I can grab the electrical trenching, read that in. Same thing, it's going to set up use the survey attribute. It also has an extra little thing here, just to show you that this attribute here where we set the drainage before, this one is actually the extent to tin. So it just allows you to, before this extend to tin option was embedded in the actual profile of the actual type in this trench profile. But when you are applying the styles and you are creating a Trimesh, you can, and it may not even be the Trimesh objects for trenching. If you've got a Trimesh in your profile and you want to extend to a tin, you can tell it at this stage here simply to extend and what the name of the Trimesh is. So it just allows you the flexibility to do it here or embedded in the particular style up there as well. So again, it then runs through the same process, a bit of a longer string. So again, at the last bit, we grab the gas, read that in. I said it's actually got the same thing, setting some information. It's also got a strip distance. So I'll actually go up to the tin surface and then come back 100 millimeters. That's what that strip distance is for. So I then profile that. I go back to my section view. Here are my services, and I regenerate. Here's my services that I've got profiled. So for the drainage one that we did before, so the long section looks quite good. So we regenerate that. You can see it's a complete profile under the road and everything as well. So basically, we're looking at those sorts of attribute information, storing them to the survey strings and also to drainage network. So most of the information that you do have for services and that sort of stuff are not always just the Trimeshes and the drainage network areas. Just forgot there was a water one there. We might just do that one while we're here. So again, there's a water network. I'll read it. That's this one here. And we go process. We'll also just create that water network. Again, back in our section view, here's our water network. Regenerate. It then extends up to the tin surface. But there are some things where some services you may have that are not necessarily the more complicated things. They may just be, locational services and things like that. So under the actual global attribute, you can then go to the services and pick up, say, dial before you dig data. So that means you can use this global attributes to set information about some unknown service, whether it's got a size or not, whether it's the levels are realistic, what accuracy it is, and possibly what owner it belongs to. So as I said, these things are user definable. These are just example ones that are shipped. So you can go into the services, and you can go grab into the SUI register the service register, and you can set up all this sort of information to apply to your data. So it's all totally user definable. So you edit it under the edit global attributes, and you just edit the ones we've already got. So you can go into register, and then you can go and create your own. So there's a list of choice boxes and reals and integers, and you can put whatever you want in the display name, whatever attribute you want, and whatever path name you want. So it just allows you the flexibility to edit the example attributes, but also customize totally what you want those attributes to be and their actual value. So here we have the Trimesh information that we've already got. So we've ran the data. So now we want to be able to take some of the information on the Trimesh. Remember I said before that the Trimesh here has some information only for drainage at the moment, but it's got some information on the string over here that I want to apply to the Trimesh. I want to do that to all the Trimeshes. They all have some reference value, they all have a length, they all have a volume. So that's the Attribute Manipulator does that. So we can run it one at a time. So if I go apply, we would then pick the model, pick the file we want and then apply it to it, but I can also put in a chain. So the idea of the chain is that you would then do this before exporting to IFC. So again, under this chain, I've just recorded the option manual process. If I go preview, it's going to grab all the data on this view and apply the drainage BIM part, which takes those string attributes and sets them as a BIM attribute. So same for the other one. This one's the project attribute. So I go to here, the option manual just records this panel, and I set up the project details, which is the one that I showed you before. So if we go run on our chain, so it's going to run this on our data, and this is our data before we export. So if I finish that, and then I update this now, so now under the drainage for this one, we have the drainage, we've got these extra things added in, the reference, the calculated length, the Trimesh, all under a tab called drainage, and we've also applied the project attributes now to that data. So I picked one of the trenches that was part of the comms and gas, and that's which were created off a survey string. They have the extra tab called survey now. So they have the survey information, drainage, and also the project information. So when you do output that before, as I said before, when you go into BIM export, IFC, right, this is the attribute that's going to tell you everything that's under that BIM exported to the IFC. So I've already done that before, so I'll have a quick look. This is in Salibri. So again, if I pick the backfill on the drainage, you can see I've now got a drainage tab with information about the drainage and also some project information. If I pick on the other strings that came from a survey, they have the extra tab for survey. So it just gives you an idea of what you can do with those sorts of attributes, and by just being actually user definable makes a big difference. So don't forget, under the 12 has its own clash detection. So all these services and information, the clashing is imperative. So under BIM, under clash detection, if we just pin that, we can set up some rules. And so those rules are one service versus another service. You can actually set up clearances around one particular service. So creates like a box around it, so you can't go any closer to that, or it will report or warn you. So you can do things like that. Each service against each service, building Trimeshes against services and things like that. So when you do run the clash detection, it will create models for the clash showing on the screen where that is. It'll also give you create a corridor if you're using some tolerances around the service, and it'll also then in this case report it to a HTML file. As well as the report to the file, it will also report to the output window as log lines where those clashes are. So if I go check and I replace the data that I'm after, it'll then bring up the HTML file. We've got quite a lot of clashes on purpose here. So we've got clashes with the gas and electricity and so forth, and with the water network, lots of clashes with the underground electricity mainly. So if I go back to 12D and just redraw my view here, you'll see that there's Trimeshes created for the tolerances around the outside of the service, and also where the service is actually clashing. So on the output window, I can go down to the service and I can use my arrow key and just search around, and it will actually highlight where those clashes are. And so if I scroll down to the stormwater, I start to look at a few things like that. You can see that there's electricity is going through manholes, and all sorts of things wrong. So by all means, make sure that the clash detection is obviously done inside 12D with this great feature before exporting any data out to IFC. It's always good to have your data correct before you do export it. So it gives you a bit of a rundown on this. We will look at other webinars, and one of the final ones at the beginning of next year will be on customizing. So we will give you a bit more information on how to create these, but there is enough in the setups shipped with 12D for you to be able to utilize the BIM objects in subsurface utilities. Thank you very much. Over to you, Lisa.
Thanks for that, Peter. The recording of today's webinar will be available in coming days through the webinars page on our website and our 12D Model YouTube channel. Keep an eye on our emails and social media for details of our future webinars and, of course, of our 2020 Tech Forum in August. Don't forget to check out the early bird discount pricing for that. If you need to contact us in the meantime, I'll pop some details on the screen. That concludes our presentation for today. Thank you all for attending, and we hope to see you at future webinars.